All right, ladies and gentlemen, here's your review sheet for our test coming up. I thought I'd do a video for it. We will have morning review, so know that we'll have morning review on Monday. All right, what is the solution for x of the following systems of equations? That means I need x, which means I need to get rid of y. So when I look at my y's, they're already lined up, and they're opposites of each other, which means I can just add these equations together. My y's are going to cancel. I'm left with 0 over there, equals 2x and negative x is x, negative 3 and 1 is negative 2. Finish solving. I have to add 2 to both sides, so 2 equals x. I don't need to worry about what y is because it didn't ask for y in this case. Next problem, which ordered pair is the solution to the equations? So again, I can solve it whichever way I want, substitution or elimination. But when I look at the problem and I see that my y's are already opposites of each other, that makes it a little easier. So I'm going to go through and just add them together. I don't have to do any other multiplying or moving around or anything. So add them together, 2x plus x is 3x. Y's cancel, 10 plus 2 is 12. Divide both sides by 3, so we're getting x equals 4. And then I have to put that into one of the problems. I usually do the first, so 2 times 4 minus y equals 10. 8 minus y is 10. Subtract 8. Negative y equals 2. Divide by negative 1. So y is negative 2, which ended up being a that I wrote over. Which ordered pair is in the solution set? The solution set is where your shading overlaps in this case. So when I look, right, I have here would be 0, 0, so that's definitely where they overlap. 1, 5 is going to be up here. That is not where they overlap. Negative 3, 3 is over here. And positive 3, 3 is up here. So the only one that works is 0, 0. I think that's it on this page. Of course, hold on. Okay, number 4. The graph of which inequality is shown in the accompanying diagram. So we're looking for a couple things. I need to know what's my y-intercept. And when I look, my y-intercept is 1. And if I check all my equations, they all have plus 1. Okay. It's a solid line, which means I can automatically get rid of C and A, because those are the greater than and less than, and that would have to be a dotted line. The other ones look like they have the same slope, so I need to know, am I shading the less than or the greater than? And since I'm below the line, that's going to be less than, because you're shading below it, less than it. What is the solution for the systems of equations? So we have to take a look to see where they intersect. This is going to be negative 1, negative 2. And there's only one solution, which was choice C. Next question. Let's see. Solve the following systems of equations graphically and check. Did we give you the graph? Of course not. Okay. Normally it would be, you would get a graph for that. But let's just sketch them out. I don't know if we're going to be able, without a graph, to be able to read the point of intersection clearly, but that's okay. So for this first graph, I have my slope is 3 over 1. My y-intercept is 0, negative 7. So that means I would start way down here. I would have to go up 3 over 1, up 3 over 1, over 1. So there's that line. For my other line, it has to be in y equals form, so I'm going to subtract 2x. So I'm going to have 3y equals negative 2x plus 12. Divide by 3. So y is negative 2/3 x plus 4. So we're starting at 4. And we're going down 2 over 3. I'm guessing that's going to be our point of intersection. Down 2 over 3. Again, not really sure what it is, but you would need to label that point. Okay, next one. solve algebraically in check, so I can either do substitution or I can do elimination. I'm going to choose to do elimination. I tend to do that one more than substitution. I see here that these are already opposite signs, so for your x's, so I have to get them to be the same number. So I'm going to take and multiply this bottom equation by 2. All right, I'm going to copy the first one down, 4x plus 3y equals 12. Multiply everything by 2, negative 4x plus 2y equals negative 32. Now I can add them. X's are going to cancel out. I'm going to get 5y. 12 and negative 32 is negative 20. Divide by 5. So y is negative 4. And then I'm going to put that in. I'm going to choose the second equation. Negative 2x minus 4 equals negative 16. Add 4. Negative 2x equals negative 12. Divide by negative 2. So x is 6. It does tell you to check. You would have to do that on the test. I'm going to skip that one. Number 8, for those of you that came to morning review, we did this, but we'll do it again here. When Tony received his weekly allowance, he decided to purchase candy bars for all his friends. Tony bought 3 milk chocolate and 4 nougat, and then there's the cost. Then he realized he didn't have enough, and he went to the store and bought an additional 6 and 4 nougat, and it cost him $6.50. So they're looking for how much did each type of the candy bar cost. That's our big question. So for my let statements, I'm going to let x equal the cost of the milk chocolate, and y is going to be the cost of the nougat, which is such a silly word. All right, now I have to write my equations. So when I do those, right, we know we bought 3 milk, 3x, 4 nougat, 4y, and that cost me $4.25. And then we had 6 milk, 4 nougat, which cost $6.50. So now I just have to take and multiply one of these equations by a negative because I already have the same number in front of the y's. So I'm going to choose the top equation because then I can just rewrite it down here and save myself some room. So this is going to give me, I'm going to rewrite it in a different color, negative 3x minus 4y equals negative 425. So when I add those, the y's cancel. We're left with 3x equals 225. I hope I did that right. Divide by 3. And you're getting that the milk chocolate is 75 cents each. So 75 cents. Okay. Then I'm going to fill that into either one of the equations. So again, I'm going to pick the top one. So 3 times 75, I believe, is 225 plus 4y equals 425. Subtract. So 4y is equal to $2. Divide by 4. So 50 cents for the nougat. All right, Alexander purchases 2 donuts and 3 cookies at a donut shop and is charged $3.30. Brianna purchases 5 donuts and 2 cookies at the same shop and is charged $4.95. Very similar to what we just did up here. So I'm going to let x equal the donuts, donut cost, and y is going to be the cookie cost. You could certainly use C and D. Doesn't matter to me. So 2x plus 3y equals 330. And then 5x plus 2y is 495. So here, now I have to do a little bit more work, right? So when I do this, I'm going to choose to eliminate my y's. And there's really no rhyme or reason for that, other than the numbers are smaller. So I have to have them be the same number opposite signs, which means I'm going to take and multiply this equation by -2, because that'll give me -6 for the y's, and multiply this one by 3, because that'll give me +6. So when I do that, right, I'm going to have -4x minus 6y equals -660, and 15x plus 6y equals 1485. Now when I add them together, the y's are going to cancel. I'm left with 11x, and on the other side, 825. Divide by 11, and you're getting, again, 75 cents. All right, so the donuts cost 75 cents. And then you can put that in. I'm going to use the first equation. So 75 times 2 is $1.50, plus 3y equals 330. Subtract $1.50. So 3y is equal to $1.80. Divide by 3 and you get 60 cents. Okay. On the set graph, the following equations graphically state the coordinates of the solution. So when I look at this first equation, I know m is 4 over 1. I know b is at 0, -1. This one's a little bit easier to graph because we actually have the graph. So there's -1. I'm going to go up 4 over 1. And then I'm going to reverse it because I want to get as many points as I can so that my line is a nice straight line. Okay. Even though I'm doing it on the smartboard, and clearly that was not a very good line. For the second equation, I have to get y by itself, so I'm going to subtract 2x. So y is equal to -2x plus 5. Slope is -2 over 1. Y-intercept is 0, 5. 1, 2, 3, 4, 5. Down 2 over 1. There's your point of intersection. Which is the point 1, 3. And we should, of course, label our lines. This was 2x plus y equals 5. And this one was y equals 4x minus 1. All right, next question. Same idea here with our inequalities. So I'm going to do the 2x plus 3y over here. So I have to get y by itself, so I'm going to subtract 2x. Divide everything by 3. So y is less than or equal to -2/3 x minus 1. Slope is -2/3. Y-intercept is 0, -1, and this is going to be a dotted line. So I start over here, 0, -1. I'm going down 2 over 3. I'm reversing it. Okay, and when I connect them, it's dotted. I have to do my test point, so I can pick 0, 0. So that means 0 plus 0 is less than -3. That is false. So I'm going to shade away from it. Okay, next one. Y minus 4x greater than or equal to 2, add 4x. Y is greater than or equal to 4x plus 2. Slope is 4 over 1. Y-intercept is 0, 2, and this will be a solid. So I start up here. I'm going to go up 4 over 1. And remember, for inequalities, we're not looking for the point where they intersect. We're looking for where their shading intersects. So my test point, if I test 0, 0, so I'm going to have 0 minus 0 greater than or equal to 2. 0 greater than or equal to 2 is false. So I don't want to shade the 0, 0. I want to shade here. And And my solution set with a great big S. Super set. Okay, next problem. Oh, those are the answers. Look at that. Just so that you can check and see. Make sure. All right, any questions? Bring them to class for morning review. And have a good night, guys.